Okay, so for number 9, we just have to find the derivative of this equation, and right off the bat, I'll look at that and I'll think to myself, okay, quotient rule. So quotient rule is low d high minus high d low over low squared, right? And so low is x squared, so low d high, well, the derivative of tangent is secant squared, so secant squared x, minus high d low, so tangent x, and then the derivative of x squared is 2x, right? All over low squared, which is x to the 4th. So I can look and try to see if any of these match. It looks like this one does. So that's going to be your answer. Okay, so moving on to number 11. This one is just a simple integral. So we can solve the integral. We have, it is the integral of 2 plus cosine theta. And so we're taking this with respect to theta. So the integral of 2 with respect to theta is 2 theta. And the integral of cosine with respect to theta is sine theta. Okay, and we're solving this from pi to 0. Okay, so plugging in 0, 2 times 0 is 0, sine of 0 is 0. So this is 0 minus, and then we have 2 pi, and then sine of pi is, that is also 0. So all we really have for this equation is just negative 2 pi. That'll be that one. Okay, so moving on to number 12. This one is an integral of a really big polynomial. This one looks super scary, but if we use u sub, we can actually solve this one pretty easily. And so what I'll do is I'll call u everything inside of that 7th power, right? So 3x squared minus 8x plus 6. So that means that du is 6x minus 8 dx. Okay, so we don't want to replace yet because we can see that 3x minus 4 is still going to cause a problem, but I can see that that's actually exactly 1/2 of what our du is, right? And so what I can say is we have du is equal to 2 times the 3x minus 4, right? So 2 times 3x minus 4 dx, right? So now we can go ahead and replace, right? And so what we'll say is we have 1/2 the integral of u to the 7th du. Awesome. So now this is a simple integral. Remember, if you have an integral of x to the n, it's always going to be x to the n plus 1 over n plus 1. So in this case, our n is 7, so n plus 1 is 8, right? And so we have 1/2 u to the 8 over 8. Okay, awesome. That should be 1/2, sorry. So we have 1 over 16, and then our polynomial to the 8th power. So let's look at our options here. It looks like it's going to be this one. Okay, moving on to question 13. We want to find the derivative given that x and y are related by the equation x cubed equals sine xy. Okay, so this one is going to be implicit differentiation, right? So we can go ahead and take the derivative of this, but whenever we take the derivative of y, we'll have to keep in mind that we'll have to put dy dx, right? Okay, so the derivative of x cubed is very easy. We just have 3x squared, and that's going to be equal to sine, okay? And then we want to take the derivative of sine xy, right? And so remember, whenever we're doing chain rule, we'll take the derivative of the outside, keep the inside the same, times the derivative of the inside, right? So the derivative of the outside, which would be sine in this case, is cosine, right? So we have cosine xy, and then times the derivative of the inside. So the derivative of the inside is the derivative of x times y, right? Now, normally that is just going to be x, right? But we're doing implicit, so we'll have to do product rule here, right? And so product rule, we will say that we do the derivative of x times y plus the derivative of y times x, right? So the derivative of x is 1 times y, so y, plus x times the derivative of y, which will be dy dx. Okay? Okay, so we're basically done. All we have left is just to rearrange and get dy dx alone on one side of the equation. So that what that'll get us is I can divide over the cosine xy times y. We'll have 3x squared over, 3x squared minus the cosine y, cosine xy times y, right? and then we can divide by the cosine xy times x, right? And that's going to be equal to dy over dx. Okay, so it looks like this bottom one is going to be our option. Okay, so question 14 is a related rates question. And so we're told that P times V equals 9 atmosphere liters, and the balloon is being squished. So currently the volume is 3 liters, and it's decreasing at a rate of 0.2 liters per second, right? And so that tells us that V is equal to 3, and dV dt is 0.2, right? Okay, we also know that PV is equal to 9. And what we want to do is we want to figure out at what rate the pressure is changing, right? So what we're going to need to do is take the derivative of this P times V equation so that we can get dP dt, right? Okay, so before we do anything, I'm going to go ahead and find P. If we know that V is 3 and that P times V is 9, we know that P is also 3, at this instant at least. And let's go ahead and take the derivative of P times V, right? So since we're taking the derivative with respect to time, right, and we know that because it's 0.2 liters per second, right? That's the giveaway. We're taking it with respect to time, right? We're going to have to use product rule, right? So it's going to be P times the derivative of V, so dV dt, plus V times the derivative of P, which would be dP dt. And that's going to be equal to the derivative of 9 is 0. Okay? And so we actually already have everything except for what we want, right? We have both the P and V and dV dt, right? And so we have 3 times 0.2 is plus 3 times dP dt, and that's equal to 0. And so you can work this out. It's actually really, really simple because the 3's will cancel out. What you'll get is dP dt is negative 0.2, and that'll be in the unit of atmospheres per second. Okay, so for question 15, we have a rectangular beam, and we want to find the width and height of the beam that give us the best strength of the beam, right? So the strength equation is equal to 6 times the width times height squared. Okay, so before we can take the derivative of this and find like the maximum, what we need to do is we need to relate W and H together. Something else they tell us is that the diameter of the log is 46 centimeters, right? So that's important because what I can do is I can draw a picture and say that we have, if this is W and this is H, we know that this is 46, right? And so we can use this Pythagorean theorem to set up an equation that relates them, right? So we know that H squared plus W squared is equal to 46 squared, right? That means we know that H squared is equal to 46 squared minus W squared. That's very helpful because we have an H squared right there. So now we can go ahead and replace it in. So we know that strength is now equal to 6 times W times 46 squared minus W squared. Okay? And now we can go ahead and take the derivative with respect to W. All right? And so that'll get us ds dW equals that 6 times 46 squared, and so that'll get us 12,696. So 12,696 times W, which will just go away. And then we'll minus 6W cubed, right? And so the derivative of 6W cubed is going to be 18W squared. Okay? And that is going to be equal to 0, right? Because we are trying to optimize the width. So whenever we're optimizing, we want to find the critical points, which means we will set it equal to 0. Okay, so we will do 12,696 minus 18. Divided by 18. And then the square root of that will get us a width of 26.55. And that'll be centimeters. And that's our answer. Okay, so for number 16, it's we have a region that's bound by the graphs of x and x cubed in the first quadrant, and it's rotated around the line of y equals -1. Okay, so before I start solving these, one thing I'll do is I will change the rotation spot from wherever it is up to the origin, right? So in this case, what I'll do is I'll move both of the functions upward 1, right? So instead of y equals x, let's do y equals x plus 1. And then instead of y equals x cubed, we'll do y equals x cubed plus 1, right? So now what we can do is we can pretend that the rotation is around the x-axis, right? And that makes it a lot easier for ourselves. So remember, whenever we're doing these integrals, it's going to be from 0 to 1, and then it's pi times, and then the equation of the line, right? Dx, right? So here we have 2 of them, so that means we have to do the taller one minus the bottom one, right? So what we'll have is the integral from 0 to 1 of pi, and that's going to be x plus 1 squared, right? Because, oh yeah, you have to square f of x, of course. And then dx minus the 1 on bottom, right? So pi and then x cubed plus 1 squared dx, okay? All right, so make sure you can get to the spot because this is most of the work, because all we have to do now is just integrate. And so I'm going to actually combine these fractions, or not these fractions, these integrals into one big one, just to make it easier on myself. So I'll take the pi out, and we have the integral from 0 to 1. X plus 1 squared is x squared plus 2x plus 1 minus, and then we have x cubed plus 1 squared. So it'll be x to the 6th plus 2x cubed plus 1. And then still we have the dx here. Okay, so we can just go ahead and integrate this. What we'll get is we'll have pi times x cubed over 3 plus x squared plus x minus x to the 7th over 7 minus, this will be x to the 4th over 2 minus x. Those x's will cancel conveniently. And then we will go ahead and plug in 0 and 1. So whenever we plug in 1, we have pi times 1/3 plus 1 minus 1/7 minus 1/2. All of that times pi will get you a answer that is equal to 2.17. Okay, so moving on, we have number 17. We want to know which of the following computes the area between the graphs of y equals 1 and y equals natural log of x between 1 and e, right? And so before I even look at the options here, I'm going to go ahead and try to set this up on my own, right? We have, it's between 1 and e, okay? So that's easy. And we're trying to compute the area between the graphs of 1 and natural log of x, right? So the first thing we need to figure out is which of these two is on top, right? So between 1 and e, is 1 higher or is natural log of x higher? Well, I know natural log of 1 is 0, right? So that means that the y equals 1 line is going to be on top. With this, I'm pretty sure what this looks like is we have 1 like this, and then natural log of x will go like this, and then we have between 1 and e, right? So we want to find like this area, right? So what we're going to do is just take the one on top minus the one on bottom, and that should get us our area of the graphs between them, right? So 1 minus natural log of x. Okay, so that will be this answer. But we aren't quite done yet because we need to look at the fact that some of the answers have a dy in it, right? And so in this case, what we just found was the dx version. And so let's take a look at the dy version. Well, the dy version would be, instead of having the 1 and natural log of x, right, it's going to have, we look at our two cutoffs, and we'll have the natural log of x as our top line, and then our bottom line would be x equals 1, right? And so the integral from that, for that one, will be, it'll be from 0 to 1, right? Because we're looking in the y direction, right? So 0 to 1. And then we have natural log of x, we want to write it in terms of y, right? So natural log of x equals y. That means that x will be equal to e to the y, right? Okay, so that'll be our first one, minus the equation of this line, which is x equals 1, right? So minus 1, and that'll be the the dy version, okay? And so that'll also get us this one as an answer.